welcome to the Boolean Brain in continuation to LeetCode Daily Challenge series, where we are solving the daily LeetCode challenges. We are on day 27. Let us take a look at today's problem statement. The title says minimum cost path with edge reversal. So we are given a directed weighted graph. Directed weighted graph with n nodes labeled from 0 to n minus 1. An array edges where edges of I equals to ui, vi, and wi, representing a directed edge from u to v with weight w. Okay. Each node u has a switch that can be used at most once. When you arrive at u1, ui, and have not yet used its switch, you may activate it one of its incoming edge. Okay. So VA to UI. Reverse that edge to UI and VI and immediately traverse it. The reversal is only valid for that single move, and using a reverse edge costs 2 into 2 times the weight. Okay. But we have to return the minimum total cost to travel from 0 to n minus 1. Minimum cost to travel. Okay. So, um, yeah, looking at the problem statement, it might sound a little difficult to understand due to this switch, but it's a very simple and straightforward implementation of Dijkstra's algorithm. Why Dijkstra's algorithm? Because we want to move from 0 to n minus 1. Minimum cost travel from 0 to n, n minus 1. And we all know that Dijkstra's algorithm used when we have a weighted graph, but with only a con where Dijkstra's cannot use when the weight is negative. Let us check if the weights are negative. And yes, I don't see weights are negative. All the weights are positive. Okay. And total number of nodes are 10 to the power 4. So n square logic cannot work. Solution containing n log n will be accepted. Okay. So we have given a weighted graph, directed graph directed weighted graph, and you have to find the minimum total cost. Okay, simple Dijkstra's algorithm is a go-to algorithm for such kind of problems. Now let's understand the tweak that they have provided. The tweak that they have provided is at any given point of age, for example 0 to 1, this age can be reversed. So it might be a little difficult to understand it while reading in the first instance, but after reading it couple of times, you should be able to understand it clearly. So 0 to 1 weight is 3, but we can have a switch using which we can flip this. So 1 to 0 can be traversed in twice of 3. So that is 6. In 6 cost, you can traverse from 1 to 0. Okay. And our end goal is to move from 0 to n minus 1. So yeah, looking at this, what we can do is we can go ahead with simple Dijkstra's standard algorithm. Only change that we will do is let's modify the adjacency list of the graph by assuming that each node, each edge has a reverse edge as well. So this condition, right? So we will modify the graph so that because it is mentioned that yeah, switch that can be used at most once, and it is present on each of the edge. So that's the reason we can basically switch from 0 to 1 can be switched to 1 to 0. Okay, now let us take a look at implementation. So this is a very standard implementation, hence I am not uh, writing it scratch. The prerequisite for this is definitely Dijkstra's algorithm. You should be aware of Dijkstra's algorithm. It's a very simple algorithm. And yeah, so initially we declare the adjacency list graph in a vector pair. And now we have to build the graph. So for each edge, we will traverse on all the edges and we will try to build a edge from U to V of weight W. So I fetch out all the U, V, and W, and I try to create a edge from U to V for weight W. The only change for this X modified condition is that I need to populate another edge starting from V to U, but with weight twice the given weight. Okay, this is the only change that I will need to do. Now the rest is the standard Dijkstra's. As you might be aware, in Dijkstra we declare a distance array. So distance array is kind of like this. 4, right? So yeah, um, 1, 2, 3, 4. Okay. So these are the four nodes that uh, represent each node. So zeroth index represents zeroth node, and one index represented the one represents the distance between 0 to 1. Similarly, 0 to 2, 0 to 3. So we have to return the this value, distance of n minus 1. We have to return. Okay. And we declare a priority queue for implementing the mean heap because it's a greedy approach. Dijkstra is a greedy approach wherein at each point we try to fetch the um, minimum distance node, and then we try to go further using that node. Okay. So that's the reason this is a mean heap implementation. So using priority queue, initially distance from 0 to 0, because as I mentioned, each element in this, right, represent distance from 0 to that particular ith node. So as we all know, for distance from 0 to 0 is 0. So I initialize it 0 and push the current element into the priority queue. That is the heap. Okay. Now, the standard implementation, like I have to keep doing my algorithm until the queue becomes empty. I try to fetch the uh, element from the queue. This we are storing vector of pair of int comma int. In first int is nothing but the current cost and use nothing but node, the node of current node and the cost of current node. Okay, and we simply pop it. And after popping, we have to ensure that if the cost if the cost is greater than the distance of u, then we have to basically simply continue. We don't want to relax it further. If not, we have to basically relax for the rest of the elements. So each for each edge in graph of u, so graph of U holds all the adjacent edges to U. We bring them all, and at each point we try to relax them. How to relax? If the distance of V is greater than the cost of current cost plus the weight. Where is this weight coming from? This weight is basically the weight present in the current edge. So if my total cost till now and the current weight is less than equals to the present distance, I have to update, right? Then I will update the distance of V to cost plus W, and I also push the current element, uh, into this Q. So my Q now holds the distance of V, which is the updated distance, the reduced one, and I updated the for this node. I this happens for all the ages and until the queue becomes empty. At the end, we have to return the n minus one, right? So n minus one is nothing but distance, this position, the distance from 0 to n minus 1 of element. We have to return this, okay? And it is also mentioned that in the problem statement, if it is not possible to reach till n minus 1 node, we have to return minus 1. Okay. So I will check if the distance, because I'm initially assigning with int max, which is a very large value, and I want to update it at each point. So I'm initially assigning it with very large value. So I will check if the distance of the n minus 1th node is very large. It means it was not possible to reach till that point. So I will simply return minus 1. Otherwise, I will return if the value exists other than int max. It means the value has been updated. So I would want to return that value. Okay, cool. So let us also quickly discuss the time and space complexity. So as you might aware, so Dijkstra's algorithm uses n plus e, the total number of nodes and edges, log n. Okay, apart from the, sorry, yeah, apart from the space complexity, we are using a space of extra space of total number of nodes and edges. So it's also O of n plus e. Okay, I hope uh, the approach and the only learning point in this problem statement was adding this extra space. Otherwise, the rest entire problem solution is of simple Dijkstra's algorithm. So only prerequisite is you should be able to know how Dijkstra's work, and I already mentioned how to identify Dijkstra's. So we have, whenever a minimum cost is given and the operation is directed weighted. On weighted, we can apply the Dijkstra's. Dijkstra's only doesn't work on negative. In this case, it was positive, so we simply applied and uh, implemented. Let us quickly try to run this up. Yes, it is passing sample. Yeah, it is also passing all the hidden test cases. So I hope everything is clear to you. If you have any doubts or queries, please do let me know in the comments. See you in the next video.